we are calculating the total current. Instead of calculating the total current flowing through this circuit. Are you getting me now? And in process for us to calculate the total current flowing through the circuit, we have to make use of the total voltage given to us here, 12 volts. Then we'll calculate use the total resistance also. Are we together? So that will eventually mean we have to calculate the resistance. How do we do that? If I may ask, what will be the resistance here? This one in series, Abi. So we can say the resistance, the total resistance at Rxz, that is Xz, will equal to what? 3 plus 3, which is equal to 6 ohms. Are you getting me now? Then we can also say what the total resistance at Ym. So the total resistance at Ym will be equal to 3 plus 3, which is also equal to 6 ohms. Ym. Are you getting me? Are we together now? Are we together? At X Z, you know, it's in series, so we add them. Remember, series resistance R1 plus R2. Same thing here, they're in series also. For Ym, that's R1 plus R2, 3 plus 3. You get it? So the total resistance along X, Y, M, which we know it is in parallel. You get it? We know that that will be 1 over the total resistance in our Xn, Xz parallel to Ym will be equals to what? I don't know if you can see what I'm doing. Let me shift it there. So we're saying our total resistance now that is there for Xz parallel to Ym, I get me, that will be obtained how? That will be obtained by saying 1 over 6, that is 1 over the Xz, which is this one here, 1 over 6, plus 1 over this one here, which is the parallel also. You know, they are parallel to each other. 1 over 6 plus 1 over 6, and that will be giving us what? How do we solve this kind of thing? That will be giving us, we look for the LCM. The LCM will be 6. 6 divided by 6, 1. Then we're having 1 plus 1 here. So I'm saying that this will equal to 2 over 6, which means 1 over 3. Are we getting it? Which means 1 over 3. So now that I've been able to get that concept now, that's our, you remember this 1 over 3 is not our final answer. This means our 1 over R, I will have to shift to the next side of the board. Okay. So from there we are able to say that what? That 1 over R, we're able to say that 1 over R as 1 over the R, X, Z, Y, M equals 1 over 3. So that resistance that is R, X, Z parallel to Y, M is equal to what? 3. Are we together? Hope you are getting the concept, please. Okay, I will explain. We said in that diagram here, we said in the diagram here, in this diagram here, that these resistors here are parallel, these resistors here are parallel to this one. This is parallel to this. So since both of them, the sum of both of them, which are series, one that's 6, and the are parallel to this one too, that is 6. You just said 1 over 6 plus 1 over 6, which is equal to 2 over 6, 1 over 3. I get me now. And to explore that info now, we're now able to say that that means to get our R, we are saying 1 over R equals to 1 over 3, then cross multiply R is equals to what? 3. That's what we have here. That's what we have here. That's what we have there. Are we seeing it now? So we've gotten our R for this place. What to? So our R for this place here is 3. Our R for this side here, our R here is 3. Have we seen that now? Our R here is 3. But remember, we have one more resistor here. And this resistor is in series with the 3 because everything here is 3. We have solved everything here at 3. These two are in series, which is 6. This two are in series again, which is 6. 6 in parallel, that's 1/6 plus 1/6. By the time you do that, you get 2/6, then cross multiply, you get 3. And that whole 3 is now in series with this one. So what will be our total resistance? Who can tell me? Who can tell me what our total resistance will be? Who can tell me what our total resistance will now be? Since we've been able to establish that it is 3 and the series with this one. So we are saying total resistance RT will be equals to what? 3 plus 1. That's that 1 ohms that is there. Remember, that 1 ohm that is there, that will be equals to 4. Look at what I'm saying. You know that in this place here, we had, in our diagram, if you look at that diagram, you had this diagram here, everything here was 3. So since everything here is 3, it is in series with this 1 here. So that means 3 plus 1. Since it's in series, 3 plus 1, which is equal to what? 4. And since we have that is equal to 4, that's our total resistance. You get it now. And remember, our V was 12. So with that, we can get our current. Since current equals to what? V over what? R. And that implies that we're having 12 volts over 4 ohms. Because our R is 4. So our current will be equal to what? 3 amps. So you guys, kudos. So that's it for that one. Can I wipe it off? Can I wipe it off? Are you done writing? Are you done writing? Write it down quickly so that I can move on. Okay, let's now move to the next. Are we done? Can I wipe it off, please? You guys should please, because of time, because you can't trust this country and their lights. This light might go off by 12 o'clock, and I'm not. Okay, so since you guys are with me, I'm going to be rubbing up now. We're going to go to the next aspect, which is conductivity and resistivity. Conductivity and resistivity. Conductivity and resistivity. Did I place it well? Not placed it well. Okay. So we go to the next aspect, conductivity and resistivity. Are we together? So we are going to conductivity and resistivity. Okay. Now the truth is that when you hear the word resistivity, resistivity is a very simple terminology that is just talking about the ability to oppose the flow of current. You should write that down. I don't think I need to write that on the board. Resistivity can be defined as the opposition, as the ability for a material to oppose the flow of current. The ability of a conductor, did I just say conductor? The ability of a material to resist the flow of current, or you can use to oppose, you understand, the flow of current. That's what we call resistivity. It tries to oppose current flow, is a restrictive force to current. I get why conductivity tries to allow, instead, is a property of a material that tends to allow electricity or current to flow through it. I get it now. And these two things are dependent on factors, and I'm going to be explaining them one after the other. And you just know that anything I say for resistivity is actually the opposite for conductivity. You get it? Anything I say for conductivity is the opposite for resistivity. So I'll just use resistivity as a point of view now, and that will help us relate to conductivity. Are we getting now? So let's like factors affecting resistivity. Factors affecting resistivity. Or we can just put it this way: factors affecting resistance. Before we go to resistivity, factors affecting the resistance of materials. Now, what are the factors that affect resistance of materials? I will start from the first factor, and that first factor is what? We'll talk about length. Now, do you agree with me? Those of you that charge phone a lot, if you notice, between a shorter wire, I want you to answer now, between a shorter wire and a longer wire, which one charges your phone fast? Between a long wire and a short wire, which one do you think charges your phone fast? Actually, I don't know if you must have taken note of it, but it is your long and your short wire that charges fast. Are you getting now? Because the shorter the wire, you reduce the barrier, or you have reduced the work. Good, that's true. Someone just said short, and that's good. So very correct, short wire, good. So it's reduced the extent to which the current has to flow from the source to your phone, right? So that means the shortness has improved the shortness has improved your conductivity. Are you getting me? So the length of the wire, the higher the length of the wire, the higher your resistivity. Because if you have very long wire, it will be hard for current to flow through. Are you getting me? Now it will have to cover a longer distance to flow from where the source to the phone. Are you getting me now? So the first factor is your length. And we say resistance is directly proportional to the length of the wire. So this statement means the higher the resistance, the higher the length, the higher the resistance, the shorter the length, the shorter the resistance. Okay, someone said my own charger is long and it used to charge that fast. You might think it's charging fast. Now, one of the things, we're keeping some things constant. Are you getting me now? We are keeping some things constant. If you want to sell it, sell it. If you want to sell your charger, sell it. So now, we're keeping some things constant. That's one thing. Why you think that it's charging fast? Maybe the adapter or the head. Are you getting me now? Maybe it has other properties that makes it charge fast. So if those properties are kept constant and you reduce the length, you even charge faster than that. Are you getting what I'm saying now? So length, we talk about length. So we're saying resistance is directly proportional to length. So another thing, factor that affects is area. Area is like it's affected in the ironical way. You understand? The larger the area, the lower the resistivity. Are you getting me now? The lower the area, the higher the resistivity. So I say resistance rather than resistivity. So I say resistance is inversely proportional to area. Are you getting me? So I'm saying R is inversely proportional to area. The last one I'll just talk about now is temperature. And I want to see who is following me properly based on our previous class. Temperature. Do you think high temperature will increase resistance or it will increase conductance? Which one do you think it will increase? High temperature, what will it favor? Is it resistance or conductance? High temperature, will it favor your resistivity or your conductivity? That's what I'm trying to say. High temperature, will it favor your conductivity or to favor your resistivity? Yeah? And the truth is, high temperature is going to favor your what? Conductivity. It's not going to favor your resistivity. I get me now. So at high temperature, resistance is what? Low. Yes. At high temperature, your resistance is low. So the higher the temperature, the lower the resistance. The because we already know that current flows more at higher temperature. I said that already when we're dealing with semiconductors and stuff. Current flows more at higher temperature. I get me. They have more conductive ability where their temperature is high. Okay. Now, joining these things together, we can say that if I join these two together now, we can say that our resistance is directly proportional to length, inversely proportional to area. True or false? True. Then we can bring in our constant, and the constant that I'm going to bring in, our constant that I'm going to bring in is called conductivity. And how do we write conductivity? Like this. Are you getting me now? This is our conductivity, real. So we can now bring in, to remove the proportionality sign, we bring in this constant and return it to equals to. So we say R is equals to what? Rho, that is resistivity over L over what? A. Are we getting that? R is equals to resistivity L over A. So make resistivity the subject of formula. When you cross multiply, you have RA. So we having RA equals to resistivity L. Then divide both sides by L. That means if you amount to what? You are having resistivity equals to RA over L. From here, you can get the unit of resistivity. What will be the unit? Using dimensional analysis. We know that R is ohms. To get the unit, we know that R is ohms. Area is meter square. Length is 9 meters. Meters is cancel meter square. Length is what? Ohms meter. So that's the unit. Measured in ohms meter. The resistivity is measured in ohms meter. Resistivity, which is this, is measured in ohms meter. Have you seen that? Finally, I told you everything here is the opposite of conductivity and conductance. Are you getting me now? So we can just say now that resistivity is equals to 1 all over conductivity. This is the symbol for conductivity, where this is conductivity. Measured in per ohms per meter. Measured in per ohms per meter. Per ohms per meter. Yes, so that's it. Have you written this down? So that's it. We are going to solve questions, maybe 2 questions, and that will be all for conductivity and resistivity. All these things are important. So if they tell you find the conductivity, in case they tell you to find the conductivity, what you are just expected to do, trust me, just get your resistivity, then 1 all over your resistivity will give you your conductivity. Are you getting me now? So that's it. That's it for that. You can take a screenshot. You can take a screenshot and write it later. Please, can I wipe up the board? Can I wipe up the board? And remember, our A is our area, and the area we're talking about is the cross-sectional area. The area we're talking about is the cross-sectional area. Cross-sectional area. And when you say cross-sectional area, we are saying it's a cross-sectional area. We're talking about the area of the base. That is the base of that conductor. Like if it's just a normal wire, a cylindrical wire, that means the base is a circle. So the area you're using is pi r square. In case they give you the r, I get me now. So I'll be wrapping up the board now. Can I wrap up the board? Our time is fast spent. We have 10 minutes to 12 now. It's because we started late trying to connect and stuff like that. So I believe next time we are using Periscope, you all know how to make use of your Periscope already. So I can wipe up the board. Let's solve questions on conductivity and resistivity. So the question says, this question says, calculate the resistivity of a wire. calculate the resistivity of the wire. Calculate the resistivity of a wire of length 2 meters. Please let's always make sure we remember to make sure all our units are accurate. We use meters for our length and areas, meters square. Let's make sure we are following accurate units. You get length 2 meters and cross-sectional area. And as you can see, this one they give us the cross-sectional area. So it's cross-sectional area and cross-sectional area 0.004 cm squared. Please, I want somebody to get hold of his calculator. I'm not with the calculator right now with me. Yes, so I can help me punch those values and give me the values. If its resistance is question area this, if its resistance is they said 3 ohms. So if you want us to calculate the conductivity, the resistivity, if the resistance is 3 ohms. Are we there? To solve this kind of a question, you have to ensure that you first of all write out your parameters. Are you getting me? Please, let's be very sharp. I need somebody to be helping me with the calculator quickly. You understand? Like fast, because I don't trust NEPA. You understand? You can take light anytime. I get me now. Although the tripod stand I'm using, it has its own personal light. As you can see, that you are seeing the reflection circle here. You get, but I don't like that. The light, the quality will not be like this. Okay, so let's be fast. Now, the resistivity, they said calculate the resistivity. So what we're looking for is resistivity. Question mark, we don't know what it is. Of a wire of length 2 meters. L is equal to what? 2 meters. And they're giving us our L as 2 meters. So meaning that what? We are not converting. The unit is correct. Area was what? 0.004 centimeters squared. How do we convert a centimeter square parameters to a meter squared? You do that by doing what? By dividing your centimeter by 100 twice. That means dividing it by 10,000. Since 100 centimeter make 1 meter, and now I didn't use square, so you are going to divide it by 10,000. So dividing it by 10,000. When you divide it by 10,000, I get me now. When you divide it by 10,000, that is what. Just don't mind what I would say, the same thing, just for accuracy purpose. Divide by 10,000 times by 1, and that does make our area be equal to what? When you do this, we'll be having 0.000004 meters squared. Yes. 1, 2, 3, 4. Yes, this is what we have. This is what we have if you divide it in your calculator. So you have this now. What again did they give us? If its resistance is 3 ohms, so our R was given to us as 3 ohms. Do you remember the formula? I gave us the formula already. We said our resistivity is equal to RA over L. And that gives us R, 3 ohms. Area is this 0.0000004 divided by our length. Remember that this one is 3 ohms. Let me put the unit 3 ohms. This one is meters square. Our length is what? 2 meters. So what's the answer? Somebody should punch it on the calculator quickly. What's the answer? I'm waiting for the answer. I'm checking. Nobody has given me the answer already. Please be fast. What's the answer? This should give you 2 year 1, 2 year 2. That will be 0.000006 ohms meter. We know the unit is ohm meter. Ohm meter. So that should be the answer. That should be the answer. Very sharp. Thank you very much, Grace and Grace. That's it. So that's it. You guys please take a screenshot. I want to drop a question for you to attempt. I want to drop a question for you to attempt. I'll give you just 1 minute to attempt it, and in the absence of anybody answering 1 minute, I'll solve it by myself. So take a screenshot of this quickly while I drop that question. Please, can I rub it off? Huh? Oh, Glory, you wrote gracious. Okay, no problem. But that, I don't know why you guys are putting funny names. I saw gracious there. Okay, but I think that it's Periscope that actually helped you to select those names. Okay, so please quickly write it down. Your screenshot. I said screenshot so that I can wipe it off now. You understand? Screenshot. Okay, so let me. It's not time. Time is just remain 5 minutes. Okay, so let us. Okay, somebody has a question. I have a question, please. Do you have a question, or you want me to ask the question? Okay, so the question says. The question says a constant wire. A constant wire has. Yeah, please, as I'm writing it, be solving it. Start solving. I know that you guys are solvers. Start solving it, drop your answer. Before I finish, as I'm talking, I want to see answer. A constant wire has a cross-sectional area. Has a cross-sectional area of 4 times 10 to the power minus 8 meters squared. They gave the unit perfectly well, meters squared. And the resistivity this is what I'm going to stop for today, of 1.1 times 10 raised to the power of minus 6 ohm meter. Then I said if a resistor of resistance, if a resistor of resistance 11 ohms is to be made from this wire, calculate the length of the wire required. Calculate the length of the wire required. So this is the last question we're solving for today. Who has gotten it? 1 minute is what I'm giving you from now. Okay, somebody has gotten the answer. Nobody. People are for my hand. Nobody. So quickly solve it. You can screenshot the question for later practice, but now you can just solve it quickly without writing the question. Later you write the question because of time. 1 minute is what I'm giving you. Okay, somebody has written answer. Desire 4 meters. 4 meters. You have made a slight mistake, Desire. 4 meters, I don't know. Let's see. Let's wait for other people answers. Are you sure it's 4 meters, or you mean 40 or 0.04 or 0.004 or I don't know? Just check. You guys should be fast. So you don't really calculate to solve all these things now. I'm waiting. I'm still waiting. Okay, while I'm solving it, you can actually drop your own answer if you are done before I'm done. Okay. So what we are supposed to do now, they're giving us cross-sectional area A, and A is equals to 4 times 10 raised to the power minus 8 meters squared, and they're giving us our resistivity, which is 1.1 times 10 raised to the power minus 6 ohm meter. They're giving us they say we do for length. Are you getting me now? And they gave us our resistance, 11 ohms. R is equal to 11 ohms. Okay, has anybody gotten it? Okay, good. Subami, very correct, 0.4, and Glory, 0.4. That's very good, very correct. So they gave us this. So we know that from this formula here, for those that didn't get it, RA over L, we make L solve the formula, we say L is equal to RA all over this, and that gives us R of 11 times A, 4 times 10 raised to the power of minus 8 meters squared. And we have our resistivity 1.1 times 10 raised to the power of minus 6. By the time you do this, you will get your L to be equal to 0.4 meters. So that's it for that. Beautiful answers from all of you. So that is all for today. In our next class, although I'm going to set an extra physics class because we need more time. Okay, and that might be next tomorrow where we'll be using our just normally we have class 3 times a week, but I'll just sacrifice one more day so that we can do much on it. Somebody wrote, Jessica, I made a mistake, it's not 0.6, 0.4. Just check very well. You get it? So I'll just set that one more day and we'll do a lot. You understand? So you guys make sure you practice. I'm going to drop questions under this aspect we've done today. Are you getting me now? I'm going to drop questions under the aspect we've done today. Are you getting me? So you guys, like now, I'll drop it now. Don't sleep, but just that we will not be on the platform to do that. I'll snap it and send it to you, and that will be your ticket to go and sleep. So that's where we stop. I believe you enjoyed the class. Please, if you guys enjoyed the class, you can just drop your comment below. All right? And remember, all these things we are doing, that's the purpose. I want you guys to make sure you give it all your mind, put your mind into it, put everything into it. Understand? And as you can see, the light just got dim because taking the light. This is Nigeria. Welcome to Nigeria. So we say about Einstein. So that's that for that. That's that for that. Okay. I want to ask you guys a question. Is the light still bright? Do you think we can just continue with this light, or do you want to sleep? Which one of them? I can just take like 30 minutes of your time and do some small stuff. Is the light still bright like this, or you prefer to go and sleep? Okay, since you guys said you want to sleep, let me not kill you people with work. Okay, so till tomorrow, we will now continue from here. I get me now. Someone said mine is doing BGB. Let's not start the madness on this place. It's a public site. Okay then, so good day everybody. And that's what we call it today. I'm going to save the lecture for those of you that want to come back to go through this again. I will save the lecture. So that's for that. So good day.